Thank you, Aaron. So as we get started here, thank you so much for joining us today on IoT Edge Data Streaming. This is a great topic that I really like to kind of dive into. Messaging and communication's been kind of at my forefront for many years, and IoT is really just extending it to a kind of a whole new level. Now, before we begin, one of the things I do like to cover is we always have these confidentiality and disclaimer statements, and I think they're so great. But in the times we live in, I think the key thing that we have to realize is that there's so much uncertainty that if I talk about anything that's we're looking at in the future, just realize that some of those things are subject to change, and just to be aware of that. So like I said, to give you just a little bit of a background, we're just going to start diving into this whole concept of IoT Edge Streaming and the concepts of communications and data distribution for IoT over the next couple of weeks. But my background is really in computer science and communications. I've been working for TIBCO for well over 20 years. Primarily focused on the data distribution side, so building out the messaging architectures and the solutions that we use for providing high performance communications infrastructure for things like integration, web services, event processing, all of those types of layers. But today, what I really want to talk about is the IoT side of things. And like I said, TIBCO's been in this business of managing and solving the impossible. And we really got our start in the connect side of things, but it really comes down to taking all that data, doing something with it intelligently so that we can start to predict and understand and make decisions in real time, or better yet, be able to predict what's going to happen in the future so that we can make decisions ahead of when problems occur. Now, IoT is a really interesting conversation. I actually spent about 1.5 years working for a lighting controls company that was diving into the IoT space. They were traditionally a manufacturing company, and they started to move into what does it mean to bring IoT into the forefront of their business. And one of the things that really started to stand out in those conversations was that IoT comes down into two fundamental categories. One is the ability to access data, and that's really what we're talking about with regards to communications. How do I get information from sensors, from manufacturing floors, from individual components, all to a location that allows me to take that information and do something with it? Now, the pieces that really, I think, come into play with regards to how this plays out, though, is that when we dive into IoT, it really comes into that challenge of what does it mean to access data appropriately? What data is of relevance? And the example I can give you is that when I was talking to a number of companies about IoT enablement, one of the biggest challenges they said wasn't the aspect of implementing the infrastructure to provide the data distribution. It was the aspect of understanding what data was relevant to the business and where do I need it to make decisions. And so that's really what it comes down to is when we're talking about the data itself, we need to understand what value that data has to a given business. And then more importantly, what actions can we derive from that specific data? So, one of the ways I thought about doing this, which is, I guess, fairly relevant because a lot of us are kind of stuck at home or aren't going into the office as much due to the current situation that we're all in, was to really look at some of the things that happen around my house. I'm kind of, held up here in my office up in my second floor, and I actually based in the Midwest of the US. So one of the things that it presents a challenge for us, especially during this time of year, is that we get a lot of hot weather, but we also get a lot of rain. And so my house is equipped with a sump pump, which is designed to basically make sure that my basement doesn't flood. If you live in the Midwest or live in any areas that are prone to flooding, you understand the relevance that a sump pump has to you. You understand the importance that that sump pump has to your security with regards to all of the things that you have stored or hoarded down in your basement from your childhood or your kids' childhood, and that you don't want those things to get ruined. And so a sump pump becomes a very key part of your housing infrastructure to make sure that your house stays dry. But what's interesting, right, is that there's so much work that we put into making sure that that sump pump works. We've had battery backups. We have backup pumps to our backup pumps if something goes wrong, when we could actually take the approach a little differently. And what we're going to do in this exercise is really focus in on that one piece, which is, so what data is of relevance to me in this particular situation? What data is of my concern? And my concern is always that I don't want that sump pump to stop working and for me to not know about it. If I can know that that sump pump is either starting to fail or if water levels are starting to rise, then I can start to do something about it. And so what we're going to build is as an IoT sensor with basic hardware components and leverage that technology to enable us to provide a communications infrastructure to gather that data, use that data in a relevant way, and provide notifications to either myself or to a number of different applications through our messaging layer. So before we dive in, just to give you a little heads up of some of the hardware we're going to be looking at and what we want to gather over the next couple of weeks and what we're going to be working on, it's all going to be built on, again, some very common pieces for the IoT or the microprocessor space. We're going to use Raspberry Pis. Any version that you want to grab is fine. We're going to need an SD card to basically store our operating system and all the software that we're going to do for tracking and sending of data. You're going to need an HC SR01 ultrasonic sensor that we're going to work and build out to connect that to monitor the water levels in our sump pump well. And then we'll have a number of wiring pieces and resistors that we will need, both 470 ohm and 1K ohm types of resistors to hook all this up. On the software side of things, we're going to leverage a bunch of open source tools to basically enable this for communication. On the OS side, we're going to just use Raspberry Pi OS. We're going to use some Python scripting and management to actually leverage the interface for the ultrasonic sensor. And then we're going to enable that to send data via our IoT kind of communications infrastructure in Eclipse Mosquito using MQTT to send that data not just to other software components within our infrastructure, but as we go through this exercise, we're actually going to enable that to bridge into things like our cloud messaging so that I can actually access that information anywhere, anytime, and allow me to monitor my current water levels anywhere I am in the world. So this is all going to be built on our TIBCO messaging platform as the foundational piece. We're also going to incorporate some pieces like our Project Air towards the end of this exercise to leverage those for IoT integration. But these components are all going to be kind of used depending on what we're trying to do and how we want to send and receive that data. So that's kind of the overview for this week. Next week, we're going to start diving into building out the hardware. We're going to start that climb and building out that IoT sensor, start to configure and set up the hardware for the ultrasonic detection, and use that to be the foundation for how we're going to start developing the software for that communications infrastructure. If you have any questions on our messaging layer or what we can provide for like MQTT, you can go to our products page on the TIBCO messaging side. We also have a number of quick access links for articles that we've written up for all of our messaging products, whether it's MQTT, Kafka, Pulsar, our web messaging, our WebSockets layer, EFTL, so all of which we're going to basically start to incorporate. If you want to look at how you can start to get early access to the Raspberry Pi side of things, go ahead and take a look at raspberrypi.org. And if there's ever any questions, please feel free to email me. My email's on the screen there, and we will start this process of building out an IoT sensor, an ultrasonic sensor for detecting water levels. While it's relevant for sump pumps, I think you'll start to see how this plays a role in building out larger scale enterprise infrastructures for bringing together data and leveraging MQTT for communications infrastructure and using that to propagate information to the right places, the right data to the right places to make the right decisions to allow you to enable IoT within your business models. So thank you, and we'll see you all next week when we talk a little bit more about the hardware itself.